proteins are natural product. So you have it, and the animal has it, and the viruses, this COVID-19 has it, they're all the same. And this virus, why can infect people? Because they share 20 amino acids, exactly as ours. Yeah, and also that's the same 20 amino acids is shared by everything known on the planet, all the living system. That's why you can eat a beef, a steak, you don't become a cow. You eat a chicken, you don't become rooster. So that's the reason we share everything in common. That's why the COVID virus infecting us. Okay, so among the 20 amino acids, some of them are nearly identical. The shape is so similar. It's like my hand, and like my hand, and it's in Y shape. The other one is like this. It did not change its structure at all. Okay, that's amino acid. This one we call it hydrophobic. They don't like water. Okay, that's why you wash your dishes with the glove. But this other one we call the hydrophilic. They like water. Okay, but the shape is the same, and the only thing is a different chemistry. Okay, so why QTY works, and is we can change hydrophobic to hydrophilic. We did not change the structure. Structure didn't change at all. That just shows the hand. Yeah. So that's the reason the QTY code is based on. It's totally based on science. And another example is hemoglobin. It's red blood cells. It's highly water-soluble protein. You will have 30%, roughly 30% hemoglobin in your red blood cells that they can carry out oxygen and transport the stuff. And so this protein is close and more than 8%. It's called alpha helix, just like my finger, the shape I just showed you. And there's another class protein called the G protein coupled receptors. But those kind, they need to be hydrophobic. They're not water soluble. But we want to take them out, make them water soluble, so we can use them, we can work with them. Yeah. So that's why the QTY code is about. We cannot take them out and then keep the structure and then keep the function. So what's the big deal? Yeah. Well, because if membrane protein is inside the buried inside, then cannot be used, cannot making biotechnology, cannot be used. But taking them out, making soluble, then can use immediately. That's why this Professor Uwe Slider, you asked me about what AVA-Trap is about. Okay, so once you take this receptor, we call it receptors, out from membrane, then soluble. Once make a protein water soluble, you can then anchor onto the S layer protein. Then the S layer protein has extremely high density. It's 1 square, let's see, my thumb, this is the thumbnail. You can anchor 4 trillion molecules on the same space. 4 trillion, it's a lot of space, a lot of molecules. So they can use, because high density, you can now coding onto the device, some kind of filter device, like filter water, Brita filter. You can now use to filter the blood system, like blood dialysis. Instead of dialysis, like kidney dialysis, kidney, you remove the ions and so on. But in this case, they selectively remove cytokines, which frequently with people who have severe COVID infection, then cause called a cytokine storm. Cytokine storm also occur in cancer treatment, mainly cancer treatment, and also sepsis shock. People get bacterial infection, also get a cytokine storm. It's an overreactive immune system. So now, if we have the water soluble, this receptor anchor on the S layer protein, which has the 4 trillion per square centimeter. So 1 square inch, you have how many tens of trillions on this. So you can filter this cytokines from your blood. Now, why you want to do the trap? Earlier, we also want to do injection into the people's body to remove cytokine, but that will take 10 or 15 years to go through FDA approval, because you put it into people's body, it takes a long time. But if you do the blood dialysis, you essentially can develop technology in 2 or 3 years, because it's not injected in the body. And then the technology for dialysis has been well worked out for the last 50 years, right? So that's it, AVA-Trap is about. So they combine 2 technologies. One is my water-soluble receptors, because that's specificity. Yeah, that's a key, specificity. And the other is acyl protein, 2-dimensional crystal. You combine those 2 and it becomes very powerful technology.